All right, welcome back. Again, I apologize for not being here to walk you through this review. I hope that you had some success with your factoring and your practice yesterday. If not, that's okay. We will work on it together. If you aren't doing your homework, that's not a really good sign. You should probably find time to fit that in, but we will do our best to help each other through this. Okay, so let's move on to radicals and exponents. So here's some basic rules, things you should have taken away from exponents. Any negative exponent tells you to use the reciprocal of the base. So if I have x to the exponent -2, my base is x. My exponent is -2, and we refer to the whole thing together, like the base and the exponent. It's called a power. I get the language a little bit mixed up, but we do really have to pay attention to it. So the reciprocal, I would like you to flip the fraction upside down. And I'll come back to this one in a second. So when we do the reciprocal, we're going to flip it upside down. I'm making that gesture with my fingers. We're just going to flip the fraction upside down. So the negative, let's talk about language for a second, evaluate. So we're actually going to figure out the answer. And if you look above the board or on the back of your formula sheet, there is, there's terminology. So evaluate, find the numerical value. That's the definition of evaluate. So we want to make sure that we're answering it to the best of our abilities. Okay, so this is kind of a two-stepper. This tells me to flip. It flip the base. Flip base. It doesn't tell me to make anything negative, just flip it upside down. So my new base is going to be 5/4. I've done the flip, so the negative goes away, and that's squared. So now, when the fraction is inside the bracket, that's applied to the 5 and the 4. So we have 5 squared over 4 squared, which is going to be 25/16. So that's what I mean by evaluate. Now, some of you may be tempted to go to your calculator. I'd really recommend that you don't do that. You've chosen the pre-cal stream. We'll use our calculator a lot this year, but we should be practicing our mental math. The calculations we can do without a calculator, we should practice that. Because in grade 12, I am going to take your calculator away for lots of the tests and quizzes and your exam. So we're going to practice it. I'm not going to take it away from you, but I don't want the answer as a decimal. I want it as a fraction. Okay, so let's get even fancier. Simplify an expression with only positive exponents. Holy Hannah. Okay, let's deal with this first. So let's deal with our outside bracket first. Our outside exponent first. This tells me to flip the whole fraction. So this is going to be 36y squared over 4x to the -4, all to the exponent 3/2. Woo-wee. What does that mean? So it wants positive exponents. So maybe let's deal with what's inside the brackets first, because I see a negative exponent, and that makes me sad. I don't know what to do. So really, this guy's on the bottom, and if a negative tells me to flip it, if he's on the bottom, he moves upstairs. So we're going to have 36 x to the exponent 4, y squared over 4 to the exponent 3/2. So notice I didn't move the 4. The 4 didn't have a negative exponent. It was just the x that had the negative exponent. I didn't move the y downstairs because it didn't have a negative exponent. The only guy who had to move was this one. All right, so we're not quite done yet. Now, if you remember what to do with a power of a power, this is back from grade 9. Notice I just wrote that little exponent of 1 on the 36. It might help me later. When there is an exponent outside, it gets multiplied by everything inside. And I did that really quick on the other one, and I didn't even really think about it. And that's 4 to the exponent 1 down here, so it gets applied to that. So we're multiplying that exponent in, so we're going to have 36 to the exponent 3 over 2. We're going to have x to the exponent 12 over 2. Remember, with fractions, it's like saying 4 over 1. We multiply straight across the top, straight across the bottom. So 4 by 3 is 12. 1 by 2 is 2. And then we're going to have y to the 6 over 2. And 4 to the 3 over 2. Okay, we're not done yet. You're like, okay, you said positive exponents are all positive exponents. We're gonna do our best. Like, we want to reduce these fractions. We don't want to leave them like that if they're being able to be reduced. And we want to talk about what this means. If you remember from your unit, the denominator told us what kind of root it was, and the numerator told us what kind of exponent it is. So what that means is I'm taking the square root of 36, and then I'm going to cube the answer. So we're going to take the square root of 36, and then we're going to cube the answer. We're going to have x to the exponent 6 and y to the exponent 3. On the bottom, I'm going to take the square root of 4, and I'm going to cube the answer. Okay, so again, denominator and exponent tells us what kind of root we have, and the numerator tells us what kind of exponent we have. So we take the square root of 36, we get 6 cubed, x to the exponent 6, y to the exponent 3 over 2 cubed. So 6 to the exponent 3. 6 to the exponent 3. I'm grabbing my calculator just because I don't want to screw this up. So that's 216 x to the exponent 6, y to the exponent 3, and I can do this one in my head. 2 cubed is 8. Now, is 216 divisible by 8? Yes, it is. So I'm going to reduce this even further. I'm going to divide those two. I'm going to get 27 x to the exponent 6, y to the exponent 3. You're like, Scallion, that was way too long of a question. And you're right, it was pretty long, but we did a lot of steps and I showed you each part of it. The better we get at these, the more efficient we'll become. So I showed you all the steps just so your note's full and complete. All right. So that's a toughie. You used grade 9 exponent laws, you used rational exponents from grade 10, so it's got all the pieces to it. The next part is we're going to simplify radicals. Okay, so remember those perfect squares we were talking about? 1, 4, 9, 16, 25, 36, 49. What comes next? 49, 64, 81, 100. There's your first 10 perfect squares. And I think that we should have those committed to memory. I know you guys worked really hard in them in grade 10. So kudos to you guys. What we're going to do here is we're going to look at 75 and we're going to say, hey, do any of these perfect squares divide evenly into 75? And hopefully you're all shouting out, hey, 25 would work. We know the factors of 75 with a perfect square in them are going to be 3 and 25. You guys all know that this one's our perfect square. That's our perfect square. And if we were to square root it, we know the square root of 25 is 5. So if you know that, you can simplify a radical. So we're going to take the square root of 25 and we're going to times it by the square root of 3. Now these, when multiplied, go right back up to here. So again, I'm not changing the value, I'm just changing the way it looks. Square root of 25, we just said was 5. I can't square root 3 without my calculator. It gets into be an irrational number, and I don't want to use decimals. So we're going to leave it as 5 root 3. Okay, so nice and easy. I say that it's nice and easy, but it can get a little bit confusing, or the numbers can get big, and that's tough to do. So that's simplifying radicals. It's like grade 10 flashing before your eyes. All right. How tall is the building? How tall is the building? Okay, here we go. 2 triangle question. What we know, if this is 20 here, we know this will be 20 right here. So it's 20. So let me grab my highlighter. I'm a big fan of highlighters. It's what I do most of the time. So I've got this first triangle here, and it tells me that my angle of depression is 15. So I've got a right angle triangle. I'm going to just pull that apart so you guys can see it. It's got an angle of 15 up here. It's got a height of 20. My right angle is right there. Now, what side would be super helpful for me to find? It would be this side. So using my trig laws, and if you don't know them, they're on the back board, sine, cosine, tan for right angle trigonometry. We're not going to spend too much time on right angle trigonometry, but I am going to expect you to know it. So we know, I have my angle here, so this is my opposite side. This is my adjacent side. And this one here, I'm not going to label, it's my hypotenuse. It's right across from the 90 degree. I'm not going to label it because I don't need it. And I find when I label all three sides, I get confused. But if I look to see what trig formula has opposite and adjacent in it, it's tan. So tan of 15 degrees is equal to the opposite over the adjacent side. I'm going to label that just A, just for adjacent. Question marks are hard to continue writing in the equation. Now, if you were in my class, I probably taught you a really fast way to do it. If your variable's on the bottom, just switch these two places. So we're going to have A is equal to 20 over tan of 15. So A is equal to, got to get my handy dandy calculator out. You want to make sure that your calculator is in degree mode. So it should say, mine's a little bit fancier. It actually says the word degree. Let me grab a different calculator. This one will say, it's kind of hard to see. Sorry, I'm trying to put it under the light. You can kind of see it here. It says DEG. Some of you will just have the letter D. You want to be in degree mode because our angle was given in degrees. In grade 12, we're going to start. What are we going to do? We're going to start with, why won't my calculator go back together? Radians. Okay, here we go. So in my calculator, I'm going to go 20 divided by tan of 15. I'm going to close that bracket, and it's going to give me 74.64. So we're going to go 2 decimal places, 74.64, and that would be in meters. So what we just found here is this distance right here. So 74.64. All right. Now that we have that, we've got a second triangle. We know that the angle of elevation is 30. We know that the bottom measurement is 74.64. We just found that. And we're trying to find this side now. Okay, so let's label my pieces together. There's my right angle. I like to redraw the pictures than trying to write everything onto the one that's given. It just makes my head happier. This is my adjacent side, and this is my opposite. Again, my hypotenuse is over here. I'm not going to label it because it confuses me. So I'm going to have tan of 30 is equal to opposite, which we don't know. This time I'm going to use the letter Q. I have no idea why. I don't want to use O just because it looks like a 0. Over 74.64. All we're going to do here is multiply these two things together. So Q is equal to, so I'm going to have tan of 30. I have to close, oops, sorry, you guys can't see that. Tan of 30, got to close my brackets, times by 74.64. And it's really important that you try this in your calculator so you know how your calculator works. Make sure you're getting these same numbers as I am. Okay, so what's the height of the building? Well, I know Q is this side, and that is 43.09. I know that that's only this portion of it. I know that this part here is 20. So I know my height is going to be 43.09 plus 20. So I'm going to have 63.09, and I need my units of measure. So my height of the building is 63.09, but I have to use my meters. Okay, so there's trig, right angle trig, really quick. Okay, now we are going to create an equation for the given function here. You might have wanted to pause at some point because I went a little fast with that one. All right, it's a linear equation. I hope you guys are really good at creating equations for a given function. This one, I'm going to have to use slope point form because the intercept isn't nice. Like it's not at -2, it's not at -3, it's somewhere in between. And just because it looks like it might be -2.3 doesn't mean that it actually is. We actually have to figure it out. So 2 points are given to me here. I'm just going to label them. So this would be 2 and -1. And this point here would be -1 and -3. So I'm looking at that point right there. Okay, so now that I have my 2 points, I'm going to use slope point form. So this is y, let me try again, y minus y1 equals m times x minus x1. All right, so what we need here is we need to find our slope. So, sorry, I'm just kind of stuck on the edge of the page. So to calculate your slope, it's your change in y over your change in x. Sometimes we say rise over run. So what we're going to do is we're going to, I'm going to start at this point, and I'm going to figure out how many points I rise up. So I go 1, 2, so I'm going up 2, so it's a positive 2, and I'm moving to the right 1, 2, 3 units, and because I moved to the right, that's also positive 3. So my slope is 2/3. All right. So I needed that, so that's good. And now I just need one of these points. I needed both of the points to find my slope, but I just need one of them. And I think, and it doesn't matter which one you use, but I think I'm going to use that one. So this is going to be my x1 and my y1. Your y and your x stay put. They're locked into the equation. We don't substitute those in. We're going to lock them in. They stay as variables. So we're going to have y minus a -1, m, which we found was 2/3, x minus a positive 2. All right, so we're going to have y plus 1 equals 2/3 x, so we're multiplying this in, and then we're going to have minus 4/3, because that's like saying 2/1. We multiply fractions straight across the top, straight across the bottom. We are going to bring our -1, we're going to subtract 1 from both sides. With fractions, I need a common denominator for those. So y equals 2/3 x minus 7/3. Now, if I convert 7/3, that's going to be -2 1/3, which is about what I said it was, but I actually had to calculate it. So this would be my equation of the line. So that's using slope point form. And if you look above the board, slope point form is there. Okay, so now we know that one. If you need to pause for any reason or need me to move, I guess you can't move the sheet. Like I said, these videos will be posted online, or you can ask to pause the video in the class. All right, so now we're going to change this equation from standard form. So standard form, we're equaling 0. And slope intercept, it's going to equal y. So we have to rearrange this equation so y is on one side and everything else is on the other. So I'm going to minus 3x from both sides. So I'm going to have -2y plus 8 equals a -3x. I want to move that 8 as well, so I'm going to minus 8 from both sides. So I'm going to have -2y equals -3x minus 8. I'm going to divide by -2, but I have to divide every term by -2. So we're going to have y is equal to a positive 3/2, because when we have a negative divided by a negative, we never really leave it like that. We write it as a positive, and -8 divided by 2 is plus 4. And now this is in slope-intercept form. Okay, moving on to domain and range. Moving on to domain and range. Domain is the controller. It is the one that comes first. It affects what's happening to the range. We usually do some math with the domain and we get an input value of the range. Usually domain is written about the x's. If we're looking at a coordinate plane, we have x's and our range would be our y's. Okay, interval notation and set notation. No one likes set notation, but everybody likes interval notation, and I'm okay with either. So the smallest term is written first. So I always think lowest on the left. So your lowest term always goes on the left-hand side. And then you pick your largest term and it gets written second with a comma. If we used round brackets, that means it's not included. And if we use square brackets, that means it is included. Set notation, we use the fancy brackets. And we do the same sort of thing, lowest on the left. We put the variable in the middle. And then we use greater than or less than signs. And I think that can get intimidating, but it's really not too bad. I'm never going to force you to do it this way, but you do need to know how to read it. You need to know how to read it. Okay, so we'll go more into that, and I'll do both of them in the next example. So discrete and continuous data. Discrete data is when there's no data in between the points given. Things would be like people, dolphins, books, cars, things like that you wouldn't have half of, right? Like that just naturally are measured in whole numbers. Continuous data might be the length of a table, or your height, or your weight, or a speed. Those can be given in increments. Like you can be 5 feet 3 inches tall. Like it can come in increments. So continuous data, we're going to connect the dots. Discrete data, we don't connect the dots. And when I say dots, I'm talking about data points. So if you have a coordinate pair, we wouldn't connect the dots if we're talking about dolphins. We're not going to measure half a dolphin. If a dolphin's missing a fin, they're not half a dolphin, right? They are part of a dolphin, they're still considered a full dolphin. If we're talking about money, I'm going to connect the dots because I can have $1.50. Things like that. So just keep in mind, if you have context, if it tells you what you're doing, like slices of pizza, you're going to buy pizza by the slice, that's discrete data. Sometimes we don't get that information, and that's okay too. Then we assume, well, we're going to look at this and we're going to do some domain and ranges. Okay, so we're going to do them in both set notation and interval notation. And we know that this data, it's a closed circle here, and the line is, we've got a line. So this is continuous data. They're connected, okay? We don't know the context of this situation, but this is what it's given us. All right, so here we go. We're gonna do interval notation because everybody likes that one better. So we're gonna do interval first. So this is a square and round brackets. You got square or round brackets. All right, so if I look at the left-hand side, I'm looking at the domain. So I like to start with the letter D, domain. So domain is my X values. How far left do we go? How far left? This has an arrow on it. So this would indicate that we're going to go on forever. And in math, we call that infinity. But because it's infinity to the left, it's negative infinity. Now, infinity is something that we can never reach. If I asked you to count to infinity, you would perish before you get there. Infinity is a concept, it's not an actual point. So we're going to say round brackets. We're not going to include infinity because you can never actually get there. Now we're going to look on our x-axis. How far do we go? Oh wait, we stop. We stop at 4. We don't go past 4, so we go to 4 here. Okay, that's good. And because it's a closed circle at 4, that means 4 is an included point. So we're going to use a square bracket there. So that's a domain. So now we're going to talk about range. So things that are happening on the y-axis here. So how low does this one go? How low does it go? It sits right on the x-axis. So that's a 0. And it sits there with a closed circle, so it's inclusive. Now again, if we look at the y-axis, we're going up, like this point's up, and it's going to continue. And it's going up in an increasing direction. So we're headed to positive infinity. And again, infinity is a concept, not a destination. So that is our interval notation. Set notation is a little bit different. Oops, too bad I couldn't spell set. Set notation is going to be your fancy brackets. People, the more you practice them, the better you get, I promise. So what we're saying here is that the x values have to be less than 4. They can be any value including 4, but less. So we're going to open a fancy oh geez, I just said they were easy and now I'm having trouble. We're going to open a fancy bracket. We're dealing with the domain, so we're going to put an x and we're going to draw a line. And then we're going to say x has to be less than or equal to positive 4. And that's that. And like I said, I'm never going to force you to write it this way, but you need to be able to read it. So range, now we're dealing with the y's. And what we're saying is y has to be any value greater than 0. So y is greater than or equal to, because we have that square bracket around there, 0. And there we go. Pretty exciting stuff. Okay, let's move on to our next one. All right, they're all connected by a line, so we know that they're continuous data. All right, so if I do interval notation for my domain, I look how far left we go. So 1, 2, 3, 4, let me count again. 1, 2, 3, 4, 5. I'm at 5 here. It's got an open circle. So for my domain, it's -5, but I have an open circle here. So that means it doesn't include it. So I'm going to use a round bracket. Then I'm going to go to the right. How far do we go? We go to +5 this time. It has a closed circle, so it's inclusive. Now we're going to look at our range. We're going to look at our range here. So how low do we go? Our lowest point is at -2. But notice this one's at -2. This one's at -2 and it's included. This one's excluded. All right, so that one's a little bit different. So we're going to say that it is excluded because we have one point that can't exist. So we're going to have -2. And we go all the way up to +2. That's my highest y value. And that one is a closed circle. Well, there's no circles there, but it's not open. So we assume that it exists. Okay, so there it is in set notation, or sorry, interval notation. Now we're going to do it in set. Open a fancy bracket. We're talking about x's, so we draw it first. And now this one's a little bit different. We put our lower limit on the left. We put our variable in the middle, and we put our upper value there. Now we got to figure out our greater than or less than signs. Because all of the pointy parts point to the left. So x has to be less than or equal to +5, but has to be greater than, and it's not equal to -5. And then we close the bracket. So for our y's, we open the bracket. Our lower limit is on the left, so -2. Y goes in the middle, upper value on the right. All my pointy parts, we just got to figure out if they have an equal to sign. It is inclusive on this side, so it will have the equal to sign. It's not inclusive on this side, so it doesn't have the equal to sign. And there you go. Easy peasy. Okay, this lesson's taking a little bit longer. I apologize. Okay, last one. Now this one, the dots aren't connected. This is discrete. And in discrete data, we can only do set notation as a list. That happens with discrete data only. But again, you have to start, open your fancy brackets, put your X, and then we're just going to list the values. So what's our lowest one? It's -3, comma, -2. Where's our next one? We're at 1. And our next one after that is at 2. And our next one after that is 5. And I'm only looking at the X coordinates there. So now we open it up for our range. We're looking at the Y values. We start at our lowest, which is -5. Our next one up is 0. Our next one after that is 1. Now notice I have 2 points that have a Y value of 1. You only have to list it once. And then our next value after that is 4. Oh, that's a bad fancy bracket. Let me see if I can do that better. All right, ladies and gentlemen, that is how you do discrete data. It has to be done as a set notation because you have no points in between. So it has to be done as a list. That's the only option you have here. Okay, so with that information, you should be able to do the second portion. There is a second part of the assignment, and I will see you guys tomorrow. Good luck.